So looking at number 1 here, let's do A. So what we do is we're going to take in square root. Whoa, since this is zoomed in, I'm going to need a significantly skinnier pen. We're going to take each of these pieces and square root them individually. I'm going to give myself a different color on that one. There we go. Whoa, that is not a pen. I love it when my screen gets grumpy. So the 7's just going to hang out up front. That's 7 times whatever we get. We're going to do the square root of 18. We're going to do the square root of x cubed. And we're going to do the square root of y to the 6th. So that 7's still hanging out. What is the square root of 18? Is it a perfect square? No. Is there a perfect square in it? Yeah. If you wanted to, we could break this up. 18, also known as 9 times 2. So we could make this the square root of 9 times the square root of 2. You can do that. Or you can type square root of 18 in your calculator. And it'll spit you out. The 7 still hanging out front. Times 3 square root of 2. We're finding pairs of perfect numbers, pairs of squares. Or you can look at your individuals, like we have variables over here, and say, how many pairs, think pairs of socks, can I make of 3 x's? How many pairs can we make? Make 2 pairs with 3 things? I could make 1 pair of x's, and how many leftover x's do I have?
2.
If I have 1 pair of things, if I have 3 socks, I can make 1 pair of socks, right? And I have 1 leftover sock. So I have 1 pair of x's and just 1 leftover x who stays inside the house. He doesn't get to come out with a buddy. With the y to the 6, 6 y's, 6 socks. How many pairs can we make? If I have 6 things, how many pairs can I make? 3. Do I have any leftovers?
No.
Nope. So we're going to have y to the 3rd. So then it's a matter of reordering things. We have, I'm going to give us kind of a little bit. So we have 7 times 3 times x times y cubed. And then I'm going to bring all the guys left in the house. I have square root of 2 and square root of x. It's all the same pieces, just rearranged so that I can simplify it. Because we're going to take that 7 times 3 and make that 21. I can't do anything with the x and the y cubed, so they're going to come down. And we're going to take my 2 and my x and put them in the same house. So face each of these individual pieces individually. Break apart your numbers and your letters. Questions on that one? Okie dokie. So let's look at our inverse stuff. I want to do B. So when we're finding the inverse, I'm just going to give a slow notation. That's when we switch our f of x for y. And then whatever it is, I have my x and y, letters only, change places. So first things first is I'm going to take my f of x, which remember was just y with a fancy mustache. and switch it out for the letter y. Y equals x minus 3 squared plus 4. The step that makes the inverse. We take our x and our y, just the x, just the y. Nothing multiplied, nothing exponented, just the letters. And make them change places. So that we have x equals y minus 3 squared plus 4. Everything else is the same. Literally the only thing that moves is the letter. Technically, that's the inverse. It's bad math grammar because we don't ever have x equals with a y smushed in the middle. So what we're going to do is we're going to solve for y and get y by itself. So what's the first thing I need to do on this step to get y by itself? What's my first step going to be? We will need to do something about the 2. What's outside of that first? What's outside even that? Yeah, we're going to start with the minus 4. Start from your outside and work your way in. So first thing I'm going to do is subtract 4 from both sides. So we get x minus 4 equals y minus 3 squared. Next thing I need to do is get rid of that square. So how do we do that? How can I make him leave? Not distribute. You're not wrong, but it's going to make it way harder if I wind up with y squared. Square root it. So I want to undo the square from this side, but whatever I do to one side, I do to the other. So we now have the square root of x minus 4 equals, and then on the right side, this cancels out with that. Now we have left is y minus 3. And we have y almost all the way by himself. What's my last step over here? Add 3. So we're going to have the square root of x minus 4. Outside that is plus 3 equals y. We could put this back into our inverse here, since this was f of x. When it's our inverse, just a reminder of that notation, that's the f minus 1 of x is square root x minus 4, the minus, plus 3. Make it really, really clear that the plus 3 is not in your square root. It's outside. That's probably the hardest one of these in here. That's why I picked that one. And sneeze. Okay, questions on the inverses or what I do with that? Okay.
Can we go over D?
D? Yeah. Very similar vibe. It's just a linear function, so it's not going to be as complicated. Let me get a different color for that barrier. Just so that we have a division between these problems here. All right, so it's the really same vibe. We're going to, first things first, switch our f of x out for a y. So my first step is going to be to change this to be y equals x plus 3 over 2. And I take my individual letter x and my individual letter y, and we make them change places. That is the step that makes the inverse. So we're going to have x equals y plus 3 over 2. Technically, we made the inverse. And I apparently wrote much bigger on there because I am already at the end of that column. What do I need to do to get this y by himself?
Multiply the 2.
Uh-huh. When in doubt and you see a fraction and you're not sure what to do, multiply by your denominator to get rid of it on both sides of your equal sign. So what we have is 2x equals y plus 3. Because this 2 and that 2 cancel out. What do we do over here to get my y to cancel, or to get my y by itself? Subtract 3 from both sides. So we're going to have 2x minus 3 equals y. And then our last step, I'm going to put it back in our inverse function notation, where we have the f minus 1 of x equals 2x minus 3. So if you have a squared in your original function, you're going to wind up as a square root. If you just have x's, like in D, you're going to wind up with another line. Questions on either of the inverse ones? Okay. So our last from Unit 6 is to simplify these. We're going to do B because A, oh no, A will do it. Let's do A so that you can do B yourself. All it is we are going to simplify each of these as far as we can. So just like we did at the very, very beginning. So the square root of 8 and the square root of x. Square root of 8, what is square root of 8 going to simplify down to?
2.
So if you want to think it that way, so think about 8 being divided up into 4 times 2, right? What's the square root of 4? 2. Can I take the square root of 2 of this guy? Or is he left over? He's left over, so he's going to stay in the house. And then can I take the square root of this x, or is he staying inside the house too? He is staying inside, so he is there. So we have 2 square root of 2x plus, let's do this guy. We can think of 18 as 9 times 2 times x, technically. What's the square root of 9? 3. Can I do the square root of 2, or is he staying in the house? Staying in the house. Does the x have any buddies, or is he got to stay in the house? He's staying in the house. So I have 2 square root of 2x plus 3 square root of 2x. When they have the same radicand is what that's called, same guy in the house, if they have matchy guys in the house, exact matches, we can add them together. 2 funky apple pies plus 3 funky apple pies. That's all that is. I've got 2 things plus 3 things. It only works if they're the exact same thing, so watch out for that. But these are the exact same thing. 2 square root of x, or square root of 2x is the same thing as square root of 2x. So if I have 2 things plus 3 things, what do we have? 5 things. 5 square root of 2x. Because this is my things. 2 things plus 3 things gives me 5 things. So you simplify each term as far as you can. And then we can add the like radicands, the like guys in the house. Gotta hit the switch on my phone because it is chirping.
We don't have to do the whole next one, but how do you do it if it has two to the second power?
All right, we'll do two of them, okay? Because there's two different formulas in this one question. Okay, but I was gonna say, how about, so that's module 6, big fat review of module 6. So that was most of January. Questions on any of that stuff? Okay, so let's look at our first one in module 7. I will do C and D because they use two different formulas. Which, hint, if we use a formula, it might be helpful to have. So our compound interest formula, it's been on the wall for like a couple of weeks because my other class was doing compound interest, but I've taken it down because you guys can't use the formulas that they have. So our amount is our principal, 1 plus or minus R over N to the Tn, where P is our starting amount, R is our rate as a decimal, T is the time, and N is all about this compounding piece. So we're going to take and fill in all the pieces we have for this problem. So we've got the Tammy deposits $6,000 into an account, paying 5.75 interest. How much money will she have after 9 years? So we're going to do the compounded weekly. So what is her principal? What is her starting amount? 6,000. This guy right here. It's that guy. We're going to use our formula, 1, and then it says it's paying interest, which means it's going to gain, which means it's going to be plus. We make our teeny tiny fraction with our rate. How do I put my rate as a decimal? The rate goes here, but 5.75%, whenever we're switching percents to decimals, we think about Beyonce. Because we go to the left, to the left. Okay? So this is going to be, and we put a 0 in, that's about 0.0575. And then the N is the compounding factor. How many of these in a year? So how many weeks in a year? And remember how many weeks in a year? 52. So our N is 52, which means when I close my parentheses, I can put that up here in my exponent too. We've got 52. We have one last piece we need to fill in here. That's our T. And they tell us that up here. T is 9. So they give you all the pieces to fill in this formula. We just have to be able to find them. And then what we're going to do is we are going to get our calculators and straight up type that sucker in. 6,000. We're going to open the parentheses. We're going to put 1 plus second column, third one down. This button right here gives us a fraction. And we can put our 0.0575. Right. Ooh, scrolled up to the top. Love that. Yeah, over 52. So, boop. Over 52. Close the parentheses. This is the raise it to the any exponent button. This little up arrow caret guy right here. We're going to hit him, and that puts us up in the exponent, and we can put in our 9 times 52. So we can straight up type the whole gosh darn thing into the calculator as it is. And then we hit enter. So she has $10,064.09. $10,064.09. All money gets rounded at 2 decimal places. If you want commas, there's one that goes right there. The commas are unnecessary. They're mathematically not a thing. They're just for ease of reading. So anytime it says compounded and it gives you any word other than continuously, this is the formula we use. If it's compounded any way, the only thing that's going to change is your n. And that's based on your compounding factor here. The only one that's different is our compounding continuously, and that has its own formula here. Our amount is still our principal, the number e to the power of our rate times time. PERT. In a minute since we talked PERT. So we're still going to be using the same information here. We still have our same principal. She still started with a gift of $6,000. E is not a variable we fill in. E is a number. It's a button in the calculator. I will remind you where it is in just a moment. The exponent on the E is where we have our rate. It's the same rate as before, and we still put it as a decimal. 0.0575. And our T is the same T. She's still talking about 9 years times 9. So it's the same pieces. They're just in a slightly different spot. And again, to go for that value, we go to the calculator again. I'm gonna clear it. We're gonna start with our 6,000 principal. To get that little E, there's a little green E over here above the ln, the natural log. We're gonna hit the green button and then the ln button to get the little E. It even pops you up into the exponent because it knows it's gonna be E to some exponent. You only use E to the exponent. So E to the 0.0575 times 9. And you can just straight up type it in. And we get $10,066.97. So we have $10,067.67. This one helps to have a calculator next to your screen or to your paper, not under your paper. When you're doing one of these problems where it has these 4 sections where you're compounding differently, it should only change by a few dollars. It should not change by thousands and thousands of dollars, unless we're talking like generational amounts of time, like 50 years. So it should be only a few dollars, and that's correct. It might only be a few cents. It could be up to 100 if we got big monies and we're doing some long time, but it's not going to be thousands and thousands of dollars. Okay, so if you're getting thousands and thousands of dollar changes, come see me with your calculator so I can see what's going on. Okay? So you have 2 more on that one that you can practice. And then on the second page, I think there's another one. Yeah, number 6 is very, very similar. You're going to use those same formulas. So number 6 is very much like the one we just did, so we're definitely not going to do 6. We will do 5 together, and I will do one of the population ones just so we can see what that's like. We will do 7 and one of 8 or 9. Okay. So 5 here, this one is a straight up, do you remember what happens? On how we can get that Y transformation, the rotating around the Y axis. And what it is we need to figure out how to change the base without really changing the base. So the way we get from f of x, which is this guy, to the g of x here, is you could either do 10 to the minus x and make all of your x's change sides. That's okay. If I do my opposite of x, it means, all right, this guy's going to flop over here. This guy's going to flop over here. This guy's going to flop over here. It makes my x's switch sides. That one's valid. The other one that we have that does this switch is if we simplify that. Negative exponents make your number flip. Exponent laws. So you could also write this as 1/10 to the x. That is a bad parenthesis, so I'm going to fix that. Those are the two ways you can write this. Because this had that reflection across the y-axis, and this is one of the only times we had that. It spun around the y-axis like I would and spun it. And then I'm going to ask you guys this. Is g of x or f of x, so g or f, which one is decaying? Which one is decay instead of growth? Let's see. So this guy is decaying. Pink. Let me get a bigger marker so we can actually see it. So is pink decaying? Or is blue decaying? It's going to be the G. I heard it. G of x is an example of decay. We read graphs from left to right, just like we read words. So it's falling. It's getting smaller from left to right. Six is just like the ones we just did, annually and continuously, so it's having you do those again. Seven is really similar. It uses a simpler interest formula because it's not a compound interest. So this will be our last formula that we need. We'll use this for the next 3. There we have our amount is our principal, 1 plus or minus the rate to the time. Since we don't have any compounding, we don't need that compounding factor. The n is no longer involved. And it's all about finding the pieces we have here. I'm going to do 9 and then we'll come back and finish 7 because I promise I have a reason. So 9, we have a town that has 5,000 people. 4% leave every year to find better jobs outside the town. How many people will be left in 7 years? So we're going to use the same formula. Our A equals P 1 plus or minus r to the t. Do we have our starting amount? 5,000, that's our principal. That's always where it starts. Is our population growing or shrinking? Which means, are we going to use the plus or the minus? The minus. What's my rate? 4%. How do I write that in my equation? 0.04. We always go to the left, to the left. 0.04. And what's our t that we're going to use? 7. And what that's going to tell us, that's going to solve and find our A. That'll be the amount of people left after 7 years. And so we type that in the calculator. 5,000 times 1 minus 0.04 to the, we use this exponent button here to get our exponent again. That gives us our any exponent of 7. Are you the right number there? I did, yay. Hello, my dear. Thanks. Okay. So just like this, and then we're going to hit enter. So we have 3,757 people. Whole numbers because it's people. 0.2 rounds us down. So 3,757 people. The amount of people is 3,757 people. So our town, we find our values and we plug them in. Sometimes we have to be careful because we are being extra. Number 7 is a little extra. Read it carefully. Filling in the values we have. What values do we have here? The 57, where's that going? Inside the parentheses. Yeah, so that's going to be our 1. Since our value increases, we're going to use the plus. Our rate, 57%. There we go, to the left, 0.57. What else do we have? 200. Where's the 200 going? Is that where our data starts? Is that the starting amount? Or is that what it is now? So where's that going to go? In the A. So they gave us the A value here. That's the 200. So be real careful. Sometimes they're a little extra. This is the 200 over here. We are asked to find how much was it worth when you found it. So what was the starting amount? That's our variable. That's the piece we don't know. How much time has passed? 10 years. We're going to put the 10 up here. And we have to solve for P. This chunk right here is all numbers. This is totally something we can put in the calculator. So what we have is that 200 equals P times that little chunk, our 1 plus 0.57 to the 10th. 90.99. Now give me 2 decimal places. P times 90.99. How do I get P by itself?
Divide.
It's exactly what we're going to do. If I divide both sides by the 90.99, I'll find out what P is. I'll find out what my principal value is. So we'll find that P, that is not what I wanted, purple. P is 200 divided by 90.99. 2.198 or 2.20. So 10 years ago, when I found this quarter, what was it worth? $2.20. Now it's worth $200. That is a very fancy quarter. So when we're looking at these, be careful of where the pieces go. For the most part, more frequently, it's going to be like 9, where we give you all the pieces and you type the dang thing in the calculator. But sometimes we like to get tricksy. Okay, so that's the first page. We will finish out the rest of this, and we'll keep working through stuff tomorrow. Just I want to make sure we get a chance to work a little bit of everything. So we'll work through more of these tomorrow, but that gives you some of them, and it gives you a little bit in 6 and a little bit in 7. So keep working through this. We got a lot more review to go, and we have logs to go in there. Dun, dun, dun. So make sure we're working on that reference page. There's a paper review, there's your Alex reviews, there's your Canvas reviews. Work on your reference sheet rules again. That blue paper. If you need an additional copy, let me know. Don't glue things on, only use one side. I will be collecting them next Monday. That way I can hold on to them and we don't lose them between Monday and the final on Wednesday. Also, to stop any dishonest friends from accidentally taking yours. Okay, so your final is a week from tomorrow. A week from tomorrow. Get yourselves ready. Alrighty.